Hello friends, welcome back again. In this video, I shall teach you chemical bonding and all its types. So let's get into the video. Chemical bonding, by definition, is a mixing or combining of two or more elements to form a compound. Now in chemistry, there are three types of chemical bonding, namely covalent bonding, ionic bonding, and metallic bonding. So by the end of this video, I shall help you understand all these three types of chemical bondings. So let's get into the video. So we shall begin with metallic bonding. On all the three types of bondings, metallic bonding is what is considered not to be a type of a bonding, because basically it just describes the structure of a metal. That is, a metal having positive and negative charges. Now if I draw a metal, it will look something like this. It will have negative charges and positive charges. These positive charges are termed as a lattice of positive charges. Why? Because they act as a glue which holds the metal together. On the other hand, we have electrons. These electrons allow electricity to pass through, and they are termed as delocalized electrons or free-moving electrons. That is all about metallic bonding. Let us look at the second type of bonding, which is covalent bonding. Now, in covalent bonding, we deal with nonmetals. Why? Because nonmetals do not gain or lose electrons. Now, in covalent bonding, we deal with nonmetals because they gain electrons and not lose the electrons. So, I want you to picture this. Covalent bonding only deals with sharing of electrons. Only sharing of electrons. So when next you hear about sharing in a question, just know that you are looking at covalent bonding. The second point is that it only takes place between nonmetals. So the first point is that it occurs through sharing of electrons and occurs between nonmetals. So to understand this better, we shall look at three particular examples. Firstly, we shall look at the bond in oxygen gas, the bond in hydrogen gas, and the bond in methane gas. Let us look at this step by step. Now, looking at oxygen, it is uniform. There are two of these oxygen molecules which are the same. And so if I'm to use a dot, I have to use a dot throughout. If I'm using a cross, I'll have to use a cross throughout. Now the first step for me to write this oxygen gas in covalent bond is to write them separately. I'll write my oxygen gas and another oxygen gas. Now keep in mind that oxygen on the periodic table has got 16 and 8. And we use the atomic number when we are dealing with bonding. So the second step here is to write the electronic configuration, which is 2,6. Now, when you are looking at chemical bonding, unless they specify in an exam, you will only consider the outermost shell. So we'll write only the outermost shell, this. and only the outermost shell of that. So we can see that we've used crosses here and dots here to show the difference even when we are pairing, so that you can see which ones have been shared. Now you must have learned in mathematics to say when you have two sets like this, which are attached at this point, this is the intersection. This represents numbers or elements found in both sides of a set. So if we are to share electrons as such in an oxygen molecule, we need to draw it as a set so that we can share those electrons and they can be found on both ends. So covalent bond always follows the rule of equal to equal, or eye for an eye. What do I mean? If I share one electron here, one must be shared here. In no event will such a thing happen such that you share two electrons from this one and one from this electron. Then you've lost your way. Another point to keep in mind is that since this oxygen molecule only needs two electrons to fill up its second shell, it means it will share those electrons to attain stability. So these two electrons will be shared because they are what are needed to balance out. So I'll share two electrons there from this one and two electrons there from this one. If I share these two electrons, four are remaining. This is what I will write up like that. And this side will be like that. And there you have your oxygen molecule of your chemical bonding. So I want you to write for me the chemical bonding in hydrogen gas and drop it in the comment section. Let us look at a more complex and last one before we move to our last type of chemical bonding, which is the methane gas. Now we know that the formula or the chemical formula of methane gas is CH4. The first step when you have a lot of elements, do not think that the question is hard. No. But the first step that we are going to do here is count how many elements we have, or in short, separate them. Another point to keep in mind is to check whether all the elements are nonmetals, of which in this case it is true. Carbon and hydrogen are both nonmetals. So what I'll do is write my carbon and 4 hydrogens there. Then you can see clearly here that we have 1 carbon and 4 hydrogens, but we know for sure that hydrogen gas is uniform to carbon. So we can use dots for carbon and crosses for these hydrogen molecules. Then follow up the first step as we did when we were writing the oxygen molecule. That is to write the electronic configuration. The electronic configuration of carbon, having 12 and 6 down, is 2, 4. And the one for hydrogen gas is 1 and 1 and 1 there. Now keep in mind that this is the first shell. So to be filled up, it needs a maximum of 2 electrons. So what we are going to do for us to write our chemical bonding, having written that, is to put the central atom in the middle. What do I mean by the central atom? The central atom is the atom that appears less in a formula. So I'll write my carbon, having known that I have to write it like a set Budan notation. Then I'll put my hydrogen, and another hydrogen there. So I'll name this as hydrogen, and hydrogen. In fact, since therefore. Now, if you look at this carbon, it has got 4 electrons in its shell. So instead of showing these electrons in this shell, and we know that it needs 4 more to add up, So it means it to share 4 electrons. Now this doesn't mean that those electrons will be shared to one hydrogen or one hydrogen or one hydrogen. It is therefore seen here that the reason they've put 4 hydrogens is so that each receives 1 electron from this carbon. So 1 electron from this carbon will be shared to this hydrogen, another one to this hydrogen, another one to this hydrogen, and finally that one. Now remember what I said. This is I for an I. So you cannot share 1 electron from this carbon to this hydrogen without it reciprocating. So what it will do is to share its 1 electron there, and then it will have a maximum of 2. The same will happen for that one, and that one. If you count the number of electrons in carbon, you see that there are 8, which fills up in the second shell. 1, 2, 3, 4, 5, 6, 7, 8. And then we can see that we have 2 electrons and 2 electrons, and then it is stable. Well, that is it about covalent bonding. Let's look at the last type of chemical bonding, which is ionic bonding. Now, ladies and gentlemen, in ionic bonding, we are dealing with transferring of electrons and not sharing. So 1 electron comes from one element and goes to another rather than being shared between 2 elements. So, in that sense, ionic bond takes place between a metal and a non-metal. So, first of all, it deals with transferring of electrons, and then takes place between a metal and a non-metal. Another name for ionic bonding is electrovalent bonding. Now, to understand this better, we shall look at 2 examples. We shall look at how we can write the formula of sodium chloride and aluminium oxide. Let us begin with sodium chloride. Now, if you want to write the bond in sodium chloride, having known that sodium is a metal and chlorine is a non-metal, what we'll do is not far from different to what we did in covalent bonding. We'll first separate these elements in this compound. So we have sodium and chlorine. But this time, instead of us sharing these electrons, we are transferring them from a metal to a non-metal, because remember, metals lose electrons while non-metals gain electrons. So what we'll do is this. We'll first write their electronic configuration. We know that this has got 23 and 11. This has got 35.5 and 17. So its electron configuration is 2,8,1, while the one for chlorine is 2,8,7. In that sense, we only use the outermost shell as well unless specified. So we'll use these brackets. Keep in mind that we use these brackets for ionic bonding and not covalent bonding. I repeat, this is for ionic bonding and not covalent bonding. So, we write our sodium with an electron in its outermost shell. We'll use dots for this one and crosses for that one. So we can just write the outermost shell there, having 1, 2, 3, 4, 5, 6, 7. Now in the final step, what we'll do is now begin to transfer these electrons. Remember, sodium is a metal. So it loses this electron to that chlorine. If this loses an electron, anything that loses an electron becomes positively charged. Let's look at this circle, for example. If I have a positive and a negative, and I lose my electron, what charge is remaining? A positive charge, right? Yes, and that is the whole idea about this. So in the final answer, you can write it as such. Having known that sodium has lost one electron and it has become a positive, you put a positive on top. Remember, one is not shown. Chlorine, on the other hand, gains that electron, so you can show this in the first step to say it has gained that electron. So if it gains an electron, it becomes negatively charged because it has gained something that is negatively charged. In that sense, the final answer for chlorine will have 1, 2, 3, 4, 5, 6, 7, but the one that has been gained was a dot. So this is your chlorine. And then your sodium, since you don't have anything in your outermost shell, write what you are remaining with, which is that and that. Then you have a dot, and a dot. So this will be your final answer. Let us look at the last example. The last example is a bit complicated, which is aluminium oxide. But remember, you have to follow the same steps and it becomes easy. So the first thing that we'll do in aluminium oxide here is to see the previous question, sodium chloride, only had one element of each type, which made it very easy. But in this case, we have two aluminiums bonding to 3 oxygen molecules. So instead of us showing all the aluminiums and all the oxygens, so I'll show you the 2 methods you can use for such type. Let us first use the long method. The long method will be aluminium, 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 oxygen, oxygen, oxygen. Sorry, you have 2 aluminiums and 3 oxygens. You know that aluminium has got 27 and 13. That gives it its electronic configuration to be its electronic configuration to be 2,8, 3, and this is 2,8, 3. This is 2,6, 2,6, 2,6. So in the first step, let us write the normal atoms. But of course, write in the outermost shell. 1, 2, 3. Then here we'll put 1, 2, 3, 4, 5, 6. Then you have another oxygen. 1, 2, 3, 4, 5, 6. Now if you look at this, you can see very well here that aluminium is a metal, so it must lose its 3 electrons to attain stability. In that sense, we can see that we have 2 of such aluminiums. So if one will lose 3 electrons, it means 2 will lose 6. And then we know, oh sorry, this was a mistake. You have to have an oxygen molecule there. So we can see that if one loses 3 electrons, it means 2 have to lose 6 electrons. Those 6 electrons have to be gained by these 3 oxygens. Now one oxygen only needs 2 electrons to attain stability. And since we have 3, it means they'll need 6. So that balances up the bonding. Now how do we show it in a simplified way instead of us writing all these boxes? What we can do is this. Write your aluminium and your oxygen, but this time instead of writing 2, put the 2 down here. That is what the 2 represents in the formula. And then put your 3 here. Please keep in mind that these 2 and 3 must not be put on top, because on top we need the charge. The next step is this one loses 3 electrons. It means it has got a charge of 3 positive. While this one gains 2 electrons, it means it has got a charge of 2 negative. Now, note that these 2 and 3 do not represent that there are 2 aluminiums or 2 oxygens. They just represent the number of electrons that have been lost or gained. In that sense, the final answer will be, since we know that these electrons have been shared, of course, showing using an arrow, you can do this. And then in the final step, you have your aluminium. Since it has lost its 3 electrons, it will remain like this. And since this has gained those 2 electrons, it will be like this. And then that's your final answer. I'll give you this question. Answer it and put it in the comment section. Well, we've come to the end of this video, and thank you for watching. Like, share, and subscribe.